this is our last video in the calculus section, and it's going to focus on applications, and we're going to look at some examples of what you can expect to see in your upcoming tests and exams. But the cool thing about calculus is that it has loads of real-life applications also. So if you plan to do a career in engineering and you want to do some dome-shaped roofs, then you could definitely be seeing calculus there. In medicine, if you want to study the effects of medicine or the growth of bacteria, then the rate of change is extremely helpful here. Okay. Calculus also has applications in physics, so things like speed and velocity, anything really to do with rate of change. And then in statistics, there are loads of places you could see it, but the one that I like the most, because it's relevant to our grade 12 syllabus, is looking at the maximum expectations and minimum expectations of a data set. Like, how would you expect things to behave? Okay. And why do I like talking about maximum and minimums? Because I know that calculus, especially at grade 12 level, links to a gradient. And a gradient, where the gradient is equal to 0, that's where I hit a turning point. And that happens either at a maximum or a minimum. So keep that in mind. Okay, let's look at 2 examples from past papers so that you can see how you will be expected to apply calculus. So here we have the equation of the line BD. Okay, so here's BD. It's part of this whole little red line here. The equation is given as x plus y equals 12. Then the point C has the coordinates there of 0 and 10. So let's pop those in. And B is given to us there as x and y. Okay, that might not seem very helpful, but I think they are trying to guide us, at least in this question. All right, write down the coordinates of B in terms of x. So what I've got now is x and y. So in other words, what they are saying is, let's change this so that it doesn't say y. Okay, so have a look at what they've given us, because B lies on this line here. So I can then substitute it out. Let's put that line just in standard form. Okay, so if we take the x over, y is equal to minus x plus 12, right? If you took that x over, it would change signs. So that's essentially what they're asking us to do. Might seem like a strange way of wording it, but what we can say to them, well then, is instead of y, I can write minus x plus 12. So that would be my first answer there. So the coordinates are x and minus x plus 12. Now they want the maximum area of, let's have a look at the shape, OABC. So in other words, they want this whole region here, the area, and then when is this area a maximum? Okay, so my brain says maximum calculus. That means I want to get the derivative and set it equal to 0, f of x. Okay, or f prime of x. All right, but what I need first of all is to figure out what the area of this shape is. Okay, so I'm not ready yet to just work out the maximum. I first of all am going to need to calculate some area. All right, so let's have a look at this. Do you know a formula for the area of a shape like this? Okay, at the moment I don't, but I can divide it into 2 shapes because my knowledge of grade 8 and 9 maths has prepared me for this. Okay, so I can say, well, here's a little square or rectangle or whatever that's going to be, and then I can maybe work out some things. Okay, so how do we work out the area of this? This is going to be length times breadth, and then this triangle is going to be half of the base times the height. Okay, what we need to realize here, grade 12s, is that this point A, because they've told us these things are perpendicular, A will have an x coordinate also of x. Okay, so I can pop that in. So I'm not worried that I've got so many unknowns. I find that's what throws my students, but it doesn't need to. X can be helpful to us, especially in a calculus question. So I'm going to say, well, that point is x and 0, because it's an intercept, and at an x-intercept, y is equal to 0. Okay, another point that I have here, let's call it point E, because I've just added it, is going to have an x coordinate there of 0 and a y coordinate of that thing there, minus x plus 12. So 0 and minus x plus 12. Okay, so that's my, at least my understanding of the coordinates there. Okay, so I can work out at least this shape here. Let's call it shape 1. Okay, so area of shape 1 is length times breadth. Okay, don't panic. The length from 0 to x is just x units times by the breadth there is minus x plus 12. That's how many units there are. Even though I don't know what x is, it's okay. Minus x plus 12. A nice challenging question to start us off. Okay, so that's going to multiply in minus x squared plus 12x. Okay, so that's the area of shape 1. Now let's work out the area of shape 2, which is half of my base times height. Okay, so the base is the same as that base was there. It's also going to be x units. All right, so we're going to say a half of x, and now we just need to find the height. It needs to be a perpendicular height, so because I've drawn in that line there, I can tell them I've drawn it perpendicularly, and so I actually need to know the distance here. Now this one has a coordinate of 10, or an intercept of 10, and this has an intercept of x minus 12. So I can actually work out that height. Let's do that. So height is going to equal 10 units minus the other coordinates, minus x plus 12. Okay, and the only reason I know what to do is because I've practiced so many of these. So that's always my encouragement to my students. Just keep practicing. So 10 minus, plus x, once we multiply that in there, and then minus 12. And so that height is now going to be x minus 2. Okay, so I can substitute that in. X minus 2, and there we have it, a half x times x minus 2. So that's going to be a half x squared, if I take that and multiply it there, and then minus x is what that's going to be. So now I can actually answer them, and I can say the total area is going to be a half x squared minus x plus minus x squared plus 12x. All right, so I've just added the area of 1 and 2. Now let's get our like terms together. So x squareds will go together, x's will go together. Okay, so that's going to give us minus a half x squared, and the blue underlining there is going to give us plus 11x. Okay, I've got area as a function of x, which makes me very happy because now I can tell them what the maximum is. Okay, so I knew the minute I saw that word maximum, I need to differentiate and let it equal 0. But at that stage, I didn't know what to differentiate. And so I had to go and work out an equation for area. Okay, so now we can differentiate this. So a of x is this, minus a half x squared plus 11x. A prime x, that's going to be the derivative. We'll take this 2. 2 times minus a half is minus 1. X to the 1 plus 11. Okay, and that is a maximum when it equals to 0. So let's do that. Okay, so now we'll end up with minus x equals minus 11. And so it's a maximum when x equals 11. And now I just need to make sure that I answer their question, because that's not the answer. The area is not 11. This is the area here. So let's finish and say, okay, well then the maximum area will be a of 11. And everywhere I see an x, I'm going to write 11. Okay, so that's going to give us 60,5 units squared. Okay, so there is a typical application question. They love to ask us to work out area, and once we have it, we can differentiate and set it equal to 0. Now let's have a look at a graph application question. So sketched below is the graph of f prime, in other words, the derivative of f of x. And then they tell us here what f of x was. Okay, that would have been a cubic function, hey, to the power of 3. Then they say determine the coordinates of A, B, and C. What's happening at A, B, and C? Those are all intercepts. Okay, so this is a parabola, even though I'm sitting here in a calculus section. And if I want to get the coordinates of intercepts, a y-intercept I want to let x equal 0, and an x-intercept I want to let y equal 0. So what I need to do is I need to actually work out what is the equation of this. And I know how to differentiate. So they've given me the full f of x function. I just need to differentiate it. So let's start by saying, well, f prime x is equal to, and then we're going to bring the 3 down, so that's minus 6x, 3 minus 1 is 2, minus 2 times 3 is 6x, plus 12. Okay, and now I'm ready. I want the coordinates of A, that's where x equals 0, so 0 and 0. A is going to have an x coordinate of 0 and a y coordinate of 12. Okay, nice and easy to read there. To get B and C, I'm going to have to do some solving. So 0 is equal to, let's divide everything by minus 6 here so that we don't have to deal with that. So that's just going to be easier to factorize. X squared plus x minus 2. Okay, how do I factorize that? 2 brackets, x times x is x squared. 2 times 1 gives me minus 2. And if I say plus 2 minus 1, that'll help me get that middle term. Okay, so what are the x coordinates there? X is equal to minus 2 or x is equal to 1. Okay, and that helps me then to say, well, B is going to be the minus 2 coordinate because it's on the negative side of the axis there. And C is going to be 1 and 0. Okay, so there we are, making steady progress. What we needed to know for sure was that we needed an equation here. Okay, so don't stress out too much about that. Just say, what do I know about parabolas? And then trust your guts. Okay, now we're going to interpret this graph here. For which values of x will f of x, so this thing here, will it be increasing? Okay, so what do we know about a derivative? Okay, we know that if f prime of x is greater than 0, then the graph is increasing. Okay, so if my derivative has a positive value, the graph is increasing. So we might be tempted, if we don't think this through, to say, oh, here's an increasing part of my graph, but that's not actually what they want. They want to know, where is this derivative positive? Okay, and it's positive everywhere above the line. So it's between B and C, and fortunately we've already worked out those values. Okay, so that was question 1. Let's do it all in the same color pen. Okay, question 2. When x is bigger than minus 2 and smaller than 1, it is increasing. Okay, what happens if it's equal to? That means I'm going to start including turning points, and at the turning point it's neither increasing nor decreasing. Hey, be careful. Okay, and then finally determine the points, the coordinates of the point of inflection. Okay, so what do I know about inflection? Inflection is where the second derivative is equal to 0. Okay, so important to know this theory because you don't want to waste time trying to dig in your brain. You want to be quick. You want to say, inflection means I need to differentiate again. Okay, so f double prime of x is equal to, that 2 is going to come down, so we're going to have minus 12 to the x. 2 minus 1 is 1, minus 6, and then plus 12 is going to fall away. Okay, and it's where that is equal to 0. Let's take this minus 12x across. So we then end up with 12x equals minus 6. Divide both sides by 12. So x is equal to a half. Okay, so now I've got an x value. Be careful because the question said coordinates. Okay, so I then need to take that and I need to pop it in there to figure out the y coordinates. So let's do that. So f of a half, always go back to the original equation, hey? Minus 2 times a half cubed minus 3 times a half squared plus 12 times a half. a half plus 20. And so that in the calculator gives us a nice little answer of 25. And so what is the point of inflection? Well, it's when x is equal to a half and y is equal to 25. Okay, so if ever they give you the graph of the derivative, and they do like to ask this every now and again, just to check that we can apply our graph knowledge, then don't forget that what you're looking at is not the graph of f of x. So I needed to think clearly, especially in the second question. I see a lot of people jumping the gun there. It's increasing where it's above the line, the original function, and the original function is decreasing where it's below the line. And then to get a point of inflection, always look for the double derivative.